Way, Heather.
Okay. And if you want all the recordings.
Oh yes, if you want the recordings, I had a lovely little. So first, there's only a couple things left in the track, so I'm not. If any of you are interested in what's left tomorrow, let me know. You can scan this. I'll show you. But if you want the recordings, come visit the Working Writers Mastermind booth. It is literally the first booth when you open the door. So you open the door to the hall, and we're right there to the right, and you can see my picture and Rose's picture, my partner, and Christopher Schmitz. We're all in one, and you can leave your email with any of us. Promise I will not be spamming that email in any way. You won't even be on my newsletter unless you really want to be, because you're going to say, oh my gosh, I want to read that book now. I need to know everything that she writes. But if you come and do that, you'll get the recordings from about 3/4 of the writer's track that we were able to cover. I think we had maybe 2 things that were double booked that we weren't able to record. So you'll get quite a few things, everything from developing your craft to bundling your books to selling to marketing to the works of people who have been doing this for many, many decades. It's all yours.
Tomorrow morning is Ask the Author.
Tomorrow morning is Ask the Author, where we have this lovely lady's lovely, lovely daughter, who is one of my publishing clients as well. So, love her. Take it away.
Thank you. Okay. Yay. Okay. So, putting science into science fiction. That is why I'm here. So, why am I the person doing this session? And it is because I have a PhD in synthetic organic chemistry, and I have been a chemistry professor for 22 years at a 2-year college. I teach 11 different classes, which is kind of crazy. I got that off my resume. I'm like, why in the world have I taught so many classes? But it's because I get bored. I've had over 3,000 students, which is kind of exciting. And in my graduate career, and a little bit beyond, but all from my work, my graduate career, I have 12 peer-reviewed research publications, and they've been cited 615 plus times. So what that means, journal articles are boring. I only recommend these if you need help getting back to sleep. They are written in past tense, passive voice. Grammarly hates me when I try to write science. They're like, this is really passive. I'm like, I'm a scientist. Like, just relax. It'll be fine. This is what is expected of me. It is changing slowly, but this particular article, I finally got access to it, was from 2002. This is my big one. And so this, you know you've made it, and you have an article. Your name is first. That's a big thing, right? First author. Research advisor is second. He always took credit second. Research advisor name at the end. They're weird. But he actually wrote this. I did all the work, but he wrote it because he was a control freak. He was, absolutely. But this is in the Journal of American Chemical Society, which is like second tier. Like you got Nature Science, they're on their own. And then you have the top journal in each field, which is kind of next to this is. And then there's all these journals underneath. So whenever my students ask what format should we put our references in, like should we use APA or MLA? Like, I don't care because we don't use any of those. Every single journal has their own way of doing it. And when you take an article and it doesn't get in the journal and you say, I want to go into a different journal, you have to redo all your references. And now there's magical computer programs that do it. But when I was in grad school, I was the magical computer program. And there was one review article. So your review articles, you're just looking at a body of research and writing a summary of the whole thing. And there was one that had like 120 references, and I got to spend 2 days reformatting the references. So yeah, you do your time in chemistry. It's super fun. But this particular article has 120 citations. So that means probably over 120 people have read it. Don't know for sure. But 120 people thought it was interesting towards their research to go ahead and cite it in probably the background section of their research. So the background section is what keeps me from publishing now. So I work at a 2-year school and I do research with students, but I don't publish it. They go and give presentations on it, but I don't want to write background sections and do all of the article searches. So I don't do that anymore, and they are fine. So science training is pretty crazy. Your first 2 years, you take very general coursework. So you might have taken general chemistry to get a chemistry requirement somewhere. You take organic chemistry, which everybody hates. It's my favorite. It's what I live to do. But then you take, in your second year, your second 2 years, you get more specific. So more detailed stuff. So you might take quantum chemistry. You might take organic synthesis. So you're just focusing on how to take molecule A, molecule B, to molecule C. Or you're taking spectroscopy. How do we actually see what we make? Okay. Then you do grad school, and you get even more detailed, right? So you choose just one particular field to go into. And then you do your graduate research work, which is going to be 4 to 5 years if your research advisor likes you. If they really, really like you, then you get to stay 4, 5, 6, 7 years because you're doing really good work for them and they don't want you to graduate. It is completely dependent on if your research advisor wants you to graduate. And you get into really, really nitty-gritty, detail-y stuff. So this paper is basically what my 4 years of research were. It's that reaction. So I'm the first in the universe, as far as we know, to run that reaction. I made 7% of it. Very first time. My research advisor was ecstatic because it wasn't 0. Okay? Then we got it up to about 70%, and that is useful. Okay? So then that reaction, that is what I know a whole lot about. I know a lot about other things, but I know a lot about this one little small piece. Okay? So the deal is when you get really detailed in science, you get to fewer and fewer people actually know anything about it. But there's these individuals who know a lot of it. So when you're writing science fiction, the more detailed you get, the more it might go awry. And we'll get a little bit into that. Oh, this is called 3 + 3 cycler additions of vanillus and activate unsaturated carbonyls.
Sounds like that's easy.
It is. Okay, here's the way it's doing
Rolls
it.
off the tongue.
No, so you have 3 atoms. 5 of them are carbon, 1's nitrogen, and you're putting them together to make a ring. Boom, that's it.
Did you play
But-
with Primal?
What?
Did you play with Primal?
I did not play with pine.
So fun.
Did not. I did make a stereoselective though, so that's the key things. I made a stereoselective, which is cool. Okay, so I want you to think about a movie moment where you lost immersion in the movie. So you're sitting with the people that you're with, and all of a sudden you just look at them. Oh, I'm so done. Okay, so just think about it, and we're gonna have some of you share your movie moments in a second. We won't pair because there's only a few people. We won't think pair share. We'll just think and share. Okay, anybody want to share? Okay, what do you got?
So I wasn't super immersed in Pandora, but as soon as they said the word unobtainium, leave me at the door. I don't want to hear unobtainium.
Unobtainium. No, you
Never
can call
in my life.
like if you're making up an element name, let's make up something better than
Yeah.
that. Pandorium.
It was meant to be funny.
And it was funny. It was a little funny.
But there's like the military sergeant guy who is evil because he has a scar and is in
Yes,
the military
yes.
saying unobtainium. Unironically. Like, if it was a comedy, like if Mel Brooks had directed Pandora,
It would be very
it would be a way better movie.
Who else has got one?
I'm going to say something that's going to be very unpopular opinion.
Okay.
Avatar, the first one.
Yeah.
I was like, the whole, yeah, I know.
The same one.
I don't know if it's one moment, but my biggest moment was really, I was like, wow, you spent $1 billion putting this beautiful thing together and hired the writers of Disney's Pocahontas. Because it's the same story, but it, just the whole, I know you want me to say a science thing, but that was
you don't
like
have to
the
say a
whole-
science thing.
It was like, it was just so in your face that I didn't, yeah.
Exactly.
I'm
You were
done. And
worried about the
literally,
story.
I'm done.
Right? Yeah, exactly. That's your focus in your world, so it's a story thing. You didn't a lack of depth of story or
Yeah.
exactly.
For me, it was The Last Emperor.
Okay.
It was such a long movie. And there was a lot of historical stuff, but they took some liberties, you know.
Yeah.
It just, it just kind of dragged on and on. There was a lot of details, like, you know, when you're writing and you put all these details about the world, it's like, this, you're telling me I don't need all of that information.
Yeah.
That's what lost me. It was just so detailed.
Just the level of detail.
Long.
Yeah.
Yeah, just dragged on.
My Dances with Wolves was mine. Oh, if I had 2 cats in a wheelchair, I would have walked out. But I was in 2 cats in a wheelchair, so I couldn't have the time. Yeah.
It's not a specific movie, but in horror movies, when they do like the really bad squeaky door effect, they do a great job. It's wonderful, like it's a suspense that they like. I don't know what's gonna happen, and then that squeaky doors, like that stock sound is like
Yeah.
Like the Wilhelm scream.
Yes,
Why?
little screens.
Yeah.
you had so much good going. You had everything you needed in the scene, and then you just added like that
Yeah.
one super it broke.
Yeah, you lost it because they just put in this cheesy, almost
Like-
door
Like,
opening.
am
It's like,
I
does
even,
nobody have 3-in-1 oil?
Yeah, I'm not even against the squeaky door sound, but like when you're building the tension to be like that, and you put that little just like, oh, ha, cute.
No,
It doesn't go.
absolutely. It's not needed. We're gonna get to that. What do you got?
I watch a lot of bad movies. I watch a lot of movies, period. Sometimes 400, 500 a year.
Oh, wow, that is a lot of movies.
A friend and I in Canada, he's in Canada, I'm down here, both decided we were going to watch 12 to the Moon this week because we had the DVD. And he was like, I never watched this. I said, oh my God, I never watched the DVD. So we watched it. And there's so much stuff like that in 12 to the Moon that it became fun to me almost immediately.
Okay.
The incompatible 12 people decided to go put a moon rocket and send to the moon just because the 12 to the Moon is a great title. The quicksand on the moon, that was really good. I really liked after you trapped in there for a while, 2 of the characters found a place that they thought maybe had a cave in the moon. How did they test this? They took off their helmets.
Oh, no.
They're like,
Like grabbing something to see if it's hot.
There were the aliens we never see that want them to leave the moon, but want them to leave the cats because they brought cats and dogs on this moon. For reasons that are beyond me.
I don't know, that part makes sense.
Actually, well, at least the cat's hot.
And they were going to keep the lovers too. Everyone else had to leave. The 2 people who loved the cats, they could stay.
The moon is
So I
fun.
love that kind of stuff, but it was all just.
Well, yeah, and if it's like tongue in cheek and stuff. Like,
No, this was straight.
oh, it was. Oh,
This is a straight science fiction movie.
okay, we're gonna have to watch it and like do some like drinking game or
That
something.
means like some MST3K for sure, like,
Yeah, that's gonna have to come out.
Not there.
Okay. So nobody said one of mine. So I have 3. One is a shared one. So this is a first one. So this is the good part of the movie. So this is Flubber from 1997. And Robin Williams is in there. I have a pointer with opener. So Robin Williams is in there. And much of this is excellent. Okay? This is how we heat things. Things can be that color. This is not bad. This is psycho. You would never put this sideways. If anything, it would be like pointed down like that. If you were distilling, you could use it that way. But like you've got a dewar, so that's full of probably liquid nitrogen, and you're like cooling something, so that kind of makes sense. This yellow inside the coil, that's not how that works. The coils are for cooling, so you put cold water through them, and then the stuff you're working with is inside. So, but like as far as chemistry on movies go, that's not bad. That looks more like a lab than what you normally get. So my friend and I were at this movie, we're both chemists, and we're like, okay, this is good. We can handle this. And you know it's flubber, it's silly. There's this amorphous goo that is sentient, okay? And this is the moment that got me. Okay, so this is supposedly the structure of flubber. This is the moment when he says, aha, if I change this cold to hot, it's gonna be magic. Now, this is only up for a split second. So when you're watching the movie, you don't have time to analyze that, so don't bother that. That's kind of weird, but not too. It's weird. But, like this number, that's like a normal chemical reaction number. That's not gonna like keep this goo from doing its thing, but whatever. So, but this structure is what's on the board. Okay, this was a big structure in 1997. Okay, they took a couple bonds out, but this was huge because it was,
Fullerene.
Mr. Fullerene. Okay, so this was buckyballs. Buckyballs were discovered as another form of carbon in the mid-90s. And does anybody know how they discovered this? You know, but you might not remember.
I want to say he didn't like pie, so they came up with this instead, right? No, that's the geodesic.
I can tell you who they named it for.
But,
Oh,
yeah.
I don't remember.
This is from candle soot. So you take a piece of paper, put it on top of a candle, analyze that, it's these. It's C60s, C70s, okay? Since then, they're doing all kinds of really cool things with it. They're putting things inside, but none of it makes something that's sentient, okay? It's candle soot. It is not sentient. So my friend and I looked at each other and we're like, oh no, what did they just do? And then we moved on, and then the guy the scientist misses his wedding twice. That's perfectly normal. That part is fully believable in this movie. He's working in lab and forgets to go to his wedding. I can see that happening with some of my colleagues in life. But this piece was just insane. So this was an example of they tried to detail it too much. They never needed to show us the screen. Okay, here's another one. Same year. Same year. Went to this one with my then fiance, now husband. So the same, okay? She is a physicist. She has solved cold fusion. Yay! This is exciting. This is what we've been waiting for. She shows the formulas. The left-hand side is the formula she did. These are Maxwell's equations. They are found in the inside cover of every physics textbook ever. Like, they didn't even try to make it look like something more interesting. Like, my husband's in quantum mechanics, I'm in physical chemistry, and we just look at each other and we're like, seriously? They couldn't be more creative with letters? Or just leave the envelope sealed. Here's the equations. Now go and save them from the world, or whatever. Okay, it's been a long time since I watched that one.
They use Pulp Fiction and it's just in a briefcase that glows when it opens.
Perfect! I can handle that.
I feel like they were going for the irony that it was just a simple thing that we just couldn't figure out.
No,
Right.
she spent all this time figuring it out and stuff, and I'm like, we know that one. It doesn't solve cold fusion. So it's always fun to go to movies. Okay, and then I'm surprised nobody said this one. This is elephant in the room style.
Yeah.
Oh,
Yeah.
yeah.
Right?
Yeah.
Right.
Yeah.
Why?
All they had to do is say midi-chlorians are, what is it?
Cause the force?
No, they don't
No.
cause it. They're correlated.
But even
All they had to do was not do it.
correct! There is a force that some people can feel. That's all we needed. And it's stronger in some people than others. Like, you could walk into a room and tell who's angry. Like, it's all good.
You ever watched Star Trek Next Generation, and every time Deanna Troi, what are they feeling? They seem angry, and they're like fuming on the screen. Thanks, Deanna.
Wow, inside check. They know that one.
Thanks, Deanna.
At least they put her in a better uniform.
Right.
We recently watched that with my daughter. It was fun. So, yeah, they just could have left this one out, right? Again, they're trying to explain something that doesn't need to be explained.
They wanted
Okay.
the blood test, I think.
Yeah, why?
But why?
Like, put them in a room with their
Have something
headphones.
that senses it.
Well, are
How
they
do you
do
get a blood test?
in the acolyte, right? They give somebody a test, like they hold up the pictures and say, "What is the picture showing?" And
Yeah.
they're looking at it, and the kid's not.
Come on. Okay, so we have a few scientific definitions that's going to help you define what you can totally mess with and what you should probably leave alone. And Dinosaur Train, it's a fabulous show. The PBS Kids show has the best definition of hypothesis ever. It is an idea that can be tested. Everybody says a guess you can test. It is not a guess. We don't guess. We read things like this, and then we decide, or we take observations of our life, and we decide what is a hypothesis that we can do. A lot of people call it a theory, right? I have a theory that putting double the blueberries in the muffin mix is going to be good. That's a hypothesis, and the college knows that I will fix them if they say this, especially administrators. They know I will take them out. But let's use the word hypothesis correctly. That'd be great. Theory then is well-supported explanation. So multiple people. So if you had a blueberry muffin recipe and everybody uses a ratio of flour to blueberries that's the same, that could almost become theory, right? All these different people, from Betty Crocker to Martha Stewart, use the same ratio. That's probably the best ratio to use. Now, if somebody else comes up with a different theory, you can go ahead and propose that. Hey, this one might be better. And then all those people might say, oh yeah, that is. I just didn't think of that ratio or that way of doing it or something. Okay? So theories are changeable. They just need some really good evidence to change them. Laws then are statements describing a phenomenon that is always true under certain conditions. These are the things that if you are writing in an Earth-like planet, you should probably keep them Earth-like, because they are the things that help our world stay together. Okay, so if you're in an Earth-like world, the law of universal gravitation is really a good one to keep in your world. Okay, so bodies of different sizes, everything is attracted to everything else. The mass of it determines the amount of the attraction. So we are very attracted to the Earth. It's kind of a big one. It's a big mass that is near us that we are attracted to. We are also attracted to the moon, but it's smaller and further away, so we're not as attracted to it. Water is attracted to it. That's why we have tides. Okay? So universal gravitation, generally a good idea. Now, if you are writing fantasy, you can throw this all out the window, because we're in a fantasy state of mind and you can do whatever you want, right? You still might want to if you want your readers to think about it as an Earth-like world, but if you don't, then go for it. You're just gonna have a lot more world building to do, because we need to know what are the laws of your world. Newton's laws of motion. Things are gonna stay in motion until an outside force is put upon them. This becomes huge if you go into space, because there isn't friction in space. Okay? On Earth, we have a lot of friction. So if you push me down the stairs, I'm going to keep going until I hit a wall, or there's been enough friction to slow me down, things like that. Okay? F equals ma. My husband teaches physics. My daughter took the physics class. I was trying to show my husband. So ended in December. Last week I said, hey Ivy, we were talking about teaching and the fact that nobody remembers everything and stuff. And I'm like, hey Ivy, what's F equal? She's like, huh? Like force. What does force equal? I don't remember. And my husband is just groaning. It's like, you didn't even get, he's like, Newton's second law. She's like, I don't remember, Dad. See? They don't even remember. So yeah, force equals mass times acceleration. If you want to move something big and you want to go fast, you have to add a lot of force. If you have a small object and you don't want it to go slow, you only have to add a little bit of force. Okay? So you're shooting arrows at things, they don't have a whole lot of mass or acceleration, so they're not going to transfer a lot of force. They might make you bleed out, but not a whole lot of force there. Unless you have magic force arrows in a fantasy world, then go for it. Okay? Equal and opposite reactions. If I push down the table, the table's pushing back at me. Okay? So that's a kind of interesting one. Again, when you go to space, that becomes a little bit more interesting because you don't have those other forces. You don't have that big ball underneath you that's holding you down as well. Lots of fun things. Okay, energy. Energy is a thing that kind of kills me sometimes. Energy cannot be created or destroyed, right? We've all learned that. Unless we go Einsteinian and we're like in a nuclear reactor and stuff, then actually even then not really. But energy can be transferred, and that's what we usually see, is that the same energy is just being transferred into different forms. So there's mechanical. So if we think about chemical energy, let's take gasoline. Gasoline is full of chemical bonds that when we put it into an internal combustion engine, those bonds are going to be broken. They're going to make pistons turn, and we're going to convert that into mechanical energy to move your car. So we're going to take chemical energy and move it into mechanical energy to do that. We have light energy. So nuclear fusion is in the sun. So nuclear energy gets turned into electromagnetic energy, so that's light. light comes to Earth, plants pick it up, turn it into chemical energy. Chemical energy then gets made into plants. We eat it, and we go into maybe mechanical if we need to move, maybe thermal to keep us warm. Maybe it's different chemical energy because we're going to make proteins in our body. Okay? It's all converting energy. A little bit of energy is often lost along those routes into thermal energy. So a lot of thermal is lost. So, this TV is warming up. It's taking electrical energy, converting it into something we can see, so there's some electromagnetic, and then we're losing some thermal along the way. But all the energy is there. If we put a closed system around this TV and measure the energy before and the energy after, it's the same amount of energy. It has just been converted. Okay? Fission inside the Earth's core, all kinds of good things going on. But it's always just converting. So I was in one of Tara Nichols' sessions on creating a magic system, and she always asks people to share what they're coming up with. And somebody said that they would take the background radiation and make it into fireball. And I'm like, no. No. There's not enough energy in background radiation to make a fireball that's going to injure someone. It's fantasy, okay, fine, whatever. But I will not read your book. I'm going to put that one back. It's not going to work for me. If you have a non-scientist, they're probably going to be fine with it. It's all going to be good. Okay, so we're going to think about what happens when we eat a muffin. Okay? We have this energy that is stored as chemical energy. We're also looking at the atoms within the muffin because matter is also conserved. So energy and matter are two separate things. Matter, the best definition is anything you can drop on your foot is matter. Okay? Now, I just read it, skimmed an article, not one of those articles, like the blog post. And it was, they made solid light. Because you can't make a solid from something that's not matter. Because light is not matter. Light is energy. So I need to do a little more digging into that one. Because I'm like, it was from a reputable source. So I'm like, okay, maybe in their definition of solid might be a little different. It's super cold, so it's not like a real thing. That's the other thing you have to worry about. Is we can make this happen at 2 Kelvin. That's not real. That's super. So temperature scale, the Kelvin scale is different than the Celsius and Fahrenheit scale. It starts at 0. So the absolute coldest temperature anything could do is 0 Kelvin. All atoms stop moving at 0 Kelvin. Earth ends, or life ends, everything ends at 0 Kelvin. And so they can get down to point something Kelvin right now. Really, really close to 0 Kelvin, in huge research institutions. And so some of these really wacky things that happen are at these places that they can get really, really, really cold. So when you eat a muffin, every molecule of that muffin is either going to become part of you or be excreted from you. And all of the energy that's in the chemical bonds that are in the muffin are going to be used to do everything your body needs to do, heat up your body, move your body, or you're going to excrete something. But you're going to try to get all that energy out. You're kind of big. You're designed to get energy out of things like carbohydrates because we're real good at that. So the molecules, let's just think about the carbohydrates. So carbohydrates in general are going to be glucose, so carbon, oxygen, and hydrogen. Those things react to form ATP, which really is just making oxygen-phosphorus bonds, providing energy to do that. That ATP can then go on and fuel your cells. It's the powerhouse of your body. If you ever need to write a book about that, please let me know. I'll proofread that section. Because I do teach biochemistry. And biologists get it wrong, so don't ask biologists about that. They do really weird things. What are you talking about? But then those molecules can either, they got to break down into two carbons with an oxygen. And that can either go to make ATP or they can go to make fat. You can put a bunch of them together and slap on your thighs. Big good to go. Or you can go into some really wacky processes to make proteins. So you can make protein from sugar. Your body's not going to like it because it takes more energy. But you can. So all of these things get broken down and built back up into the molecules we need, or they just get excreted. Okay, so you have two main routes of excretion. It gets taken one of those two things. Okay, so there's our science background, a little bit of science. So how do you keep science from making that face? They read your stuff or watch your movies. Okay. So the first thing is don't be super detailed. You don't have to. You're going to use broad correct strokes. We're going to have a little tiny reading. Okay, so there's a lot of science, I assume, but I don't know because I don't know all this. Okay, I knew a little bit. Okay, there was one part that I was, and I'm like, hey. Okay, so here, rather than restore the site, he chose to have it replaced with a programmable optic monitor. If you look at him, unless you knew he had only one working eye, you would have never have guessed it. Tatsu would tap a pattern on his temple, and through the optical monitor visible only to him via signals sent directly to his brain, he could manage his ship's operations, handle communications with ocean administrators at Global Union headquarters, and enjoy incoming entertainment and headlight programs. Okay. Does this beautiful author ever say how it interfaces with likely the optic nerve? No, and that's okay. That's good, because if that had gone awry, I would have been like, oh, come on, really? That doesn't work. That wouldn't work. But as it is, most people are just going to read that and be like, oh, cool, he's got a cool thing in his eye. And I was like, how would you do that? Okay, so they have audio ones now, right? So this isn't a huge leap that we would go from an audio thing that does that to video. Like, so we got an optic nerve, so does it clamp onto the optic nerve? Like, I don't know, but it got me thinking, how could it work? And that's way better. That's what you want to do to a scientist rather than, oh no, that's totally would not work. Okay, you want to figure out how it would work. Okay, so then we got Joe Prosik's 99 Town. In this one, they are 80 years in the future. If you like car chase scenes, oh yeah, this is your one. Really, it's a cool book. I enjoyed it a lot. I also love Jerry's book, but it has a lot of characters, and sometimes I have problems with lots of characters. So I will totally read the next one, but I have to take a little break. So 99 Town, they're 80 years in the future, and they have implants. Okay, so it hooks into the back, and he starts off saying that it controls your chemicals. So like you tell it, I want to go to sleep. So it gives you the chemicals you need to go to sleep. I might have chosen different chemicals, but the ones he chose are fine. He never, as you go through the book, he keeps adding little details about it. Okay? They're pretty good. At one point, he does say the side is a kidney bean. And I'm like, oh, that could be problematic. Never goes into which is okay, that's good. I was hoping he didn't. Like, you know, what quantities are they doing? How is this administered? Like, there were still a lot of questions that I asked that he didn't. But there were, like, when he said the size, I'm like, I was picturing something a little bit bigger, like more like an insulin pump type thing or something. Like, if you're gonna have all these different chemicals that he kept adding in, like, you have to keep them separate. So I don't understand, you know, I don't know how you keep them separate. And maybe it's really small, and maybe you have to, like, recharge it or replay, whatever. So it got really close to being a little cringy, but he held it in, and it was good. So that was a really cool concept that, like, they can follow you and see what is happening to your chemical levels, and then, like, if you're about to do something bad, they just, like, arrest you early. Yeah, a little scary there too.
It's never gone wrong.
No, oh, it goes wrong. Yeah, of course it goes wrong. Of course.
Right, yeah, exactly.
So how do you get your information? Okay, AI can help with this a lot. So AI generally does really good for well-known science. If you want to know which hormones are going to help you fall asleep at night, throw that into Google search, or I would just do AI now because it's gonna put it together in a nice place, and it gives you the references. So you can go grab the references then and see what it's doing. So if you're doing kind of some well-known stuff, that's a great first step. It can also summarize research articles. I learned this from my students. So if I took my research article and said, summarize this in 500 words for a non-chemist, it can do a pretty good job of that. So my kind of upper level students did that for their project. I'm like, that's actually brilliant. Yeah, I like that a lot. So a good way to kind of get to it without getting crazy and not making yourself fall asleep. I always said that the ink they used to, we had these hard copy when I was in grad school. They used to write journals with narcotic ink so that I would always fall asleep. Yeah, it was good. YouTube, if you need some basic stuff, Crash Course, Mr. Dave Explains, and TED Talks are great. Mr. Dave Explains, he looks like my husband Dave, so like I'm in love with Mr. Dave Explains. Like, what husband on YouTube? Like he looks very like weird, oddly similar. But Crash Course has really nice videos too. My students really love those. And they just go into really basics, like you need some equilibrium, you need some acid-base chemistry, you need, basic stuff. You can get that from there. And they do all kinds of different fields. Mr. Dave, all kinds of stuff. Okay, so then you can reach out to someone, okay? Academics are pretty much suckers. But you have to have the right person. If you reach out to me about geology chemistry, I'm not going to be helpful. If you reach out to me about drugs for the pharmaceutical industry, you got it. You got the right person. To someone, and like you would put it in, I have questions about this topic. If you are not the person to be reaching out to, you know somebody who knows about that stuff. Okay, that's great. Generally, don't go to an R1 institute and ask them for assistance. They don't got time. They don't have time for me. I had one of my students reach out to somebody about an experiment they were doing to make sure it was safe to do in an undergraduate laboratory, and they said, "Well, here, go reference the journal articles." Like, we wanted like practical. Has anybody blown themselves up doing this type of thing? Like, can you get me a TA who teaches this or something? I don't know. So, two-year colleges, we're pretty much suckers. And we have office hours. Okay, so I have office hours that nobody comes to every single week. So if you say, could I come to an office hour and talk with you for 20 minutes about this? Sure, come on in. I literally have nothing going on during that time. I could find something to do, but it is a time where my door is open and I'm available, either virtually or in person. Okay. If you have the time and the budget, then you do some stuff like this. This is just geek candy. Okay, this is good stuff. So I got one here. Okay, so this, of course, the Martian is on Mars. Everybody died. They're not planning on him being there very long, but there he is. The suit did its job admirably. Sensing the drop in pressure, it constantly flooded itself with air from my nitrogen tank to equalize. Once the leak became manageable, it only had to trickle new air in slowly to relieve the air lost. After a while, the CO2, carbon dioxide, absorbers in the suit were expended. That's really the limiting factor to life support, not the amount of oxygen you bring with you, but the amount of CO2 you can remove. In the hab, I have an oxygenator, a large piece of equipment that breaks apart CO2 to give the oxygen back. But the spacesuits have to be portable, so they use a simple chemical absorption process with expendable filters. I've been asleep long enough that my filters were useless. The suit saw this problem and moved to an emergency mode the engineers called bloodletting. Having no way to separate out the CO2, the suit deliberately vented air to the Martian atmosphere, then backfilled with nitrogen. Between the breach and the bloodletting, it quickly ran out of nitrogen. All it had left was my oxygen tank. So it did the only thing it could to keep me alive. It started backfilling with pure oxygen. I now risk dying from oxygen toxicity, as the excessively high amount of oxygen threatened to burn up my nervous system, lungs, and eyes. An ironic death for someone with a leaky spacesuit, too much oxygen. I'm like, oh, that all makes sense. And oh my gosh, and I would never think of that. Right? It's like all chemically sound. It's all like, it's and they get some more stuff that's more technical stuff that is still just like amazingly good and awesome. So if you have the right people that you can, and the budget that you can bring on others to help, then you can do some things like that. Because I'm sure Andy Weir does not know that.
He crowdsourced a lot of it, I think. Didn't
Yeah,
he crowdsource it from the internet?
I don't know, but yeah, that would make sense, right? You're getting these people, getting the people with the knowledge, and we're easy targets. Like put our name somewhere in it, and I'm like, woo. The Expanse have really cool stuff. I know I had to put it in there. I know. So my brother's like, you have to read The Expanse, and I had the same problem. Too many characters. Like it's just so much.
I was gonna say, if you like The Expanse, you'll like my books, and you're like too many characters.
I know. It's no. When you first said that, I'm like, well, I'll make it through it because I love her. But it's a lot. So I have not read the second Expanse yet because I'm like, I actually live. I still can't handle it. Too many people to keep track of. I have too many people in my life to keep track of.
The TV shows.
I fell asleep. First episode. So another problem. Don't have to watch TV. Like 400 movies a year. How do you have that time? Someday, maybe someday.
Came back to the reason of The Expanse for a long break, and I'm like, who are all these men?
Who are these people?
Like go back then.
And also, I was like, where is the cool noir? Yeah.
There you go. So there is second science. So you can read up topics. So I have a stack of perfectly reasonable books that the normal person can read about science. This one on Kindle, and I had to buy a copy. Show you guys. This Packing for Mars. Mary Roach, everything Mary Roach reads is amazing. If you're going to write about dead bodies, read her book about dead bodies. So amazing. This is all about space and how you can live in space. Everything from how you poop in space, how your bladder works in space, welding in space, just so much really cool, crazy stuff. She got into NASA. She got to go on Vomicon. She purified her own urine and took it to a lunch meeting, okay, with somebody else that was reading their purified urine, right? So,
That's a weird lunch day.
and the cashier's like, what do you have to abolish with urine? Purified, charcoal filter, yeah, let's just, so super crazy, how to have sex in space, zero G sex. They claim that nobody's actually done it, but there's like some secrets that are, I know. So super amazing book. I could not put it down. So amazing. Is different chemistry in the movies. These Dr. Joe Schwartz just does little ones about everyday chemistry. So just lots of little things. My students really like reading those. Uncorked, Science of Champagne. If you take a absolutely clean glass, wipe it with a dust-free rag, pour champagne in it, it will not have any bubbles. Because you have to have nucleation sites, and your dust in your glasses is the nucleation sites. So if you go to somebody's house and their champagne or soda or whatever, carbonated anything, has a ton of bubbles in it, their house is dusty. It's my house, but their house is dusty. If you want really amazing champagne, make sure your glasses are up for a while in your house. Kind of, get them out of the cupboard, have them out and about a little bit so they get a little dust in them, and then you'll have nice bubbling. I know, it's crazy stuff. And
these get laser etched glasses, so it creates those sites.
Okay,
Laser.
so I can have my husband go down and do our laser.
Yeah.
We have one of those.
Then you don't have to drink dusty champagne.
And then, dusty bubbles. And then there's fun things like the history of poisons and the elements of murder. Okay, so like students buy these books, it's great. And so you can learn about, if you want to use poisons, this book will tell you how poisons have been used throughout the ages and how people kill their husbands and such. So these are out there and they're much more accessible than the next, which would be textbooks. They've come a very long way. Right, I'm using some textbooks now that are so much more readable than old textbooks. So again, if you have a contact in science, and you're like, what's a good textbook in your area? I would ask someone, because what part of our job is reviewing textbooks. So that is a thing you can do. And then all else fails, get a journal article and try to stay away. Okay, last thing. If you are interested in portraying science laboratories, things like that, ask for a tour. Because the one on the left, she doesn't wear goggles. That's a problem. Literally this thing, this adapter is pointing right at her face. Like if she boils that, it's coming out her face. Like that's not good. That's not how that's used. And of course, nothing is blue. Basically, things that are blue in lab, you probably took some blue Sharpie and put it in water and you're trying to make your advisor think you're doing something. We had somebody that did that. We have a bunch of flasks going and he just put the Sharpie in them. This is what a real lab looks like. It's a lot less colorful. I mean, there's color, there's orange tubing, that's exciting. But the cool thing about this setup is that this is how you do reactions under nitrogen atmosphere. Because oxygen reacts with everything. Oxygen's a problem. You don't want oxygen to react with your reaction. So you hook up your little flask, you hook up this tube, you pull vacuum on it, right? So this line goes out to a vacuum line. So you pull all the air out, and then you replace it with nitrogen. So then you do your reactions under nitrogen, which is considered an inert atmosphere. Nitrogen is not reactive. That's why we breathe it. It works really well. And then we have this cool thing here. This is in Flubber, they used this correctly, probably. This is cooling. And this makes sure that when there is oxygen in your system, because it's coming out of here, it doesn't blow up things. Yeah, because that's generally a bad idea. If you take this off at the end of the day and there's blue liquid in it, blue liquid is liquid oxygen. Yeah, yeah. You just turn on the vacuum and let that warm up. Yeah, it only happened to me once. There was only once that I had liquid oxygen in my line. But yeah, that can go boom real quick. But I mean, there's all kinds of danger here. It just doesn't look it. Okay. So yeah, things explode all the time. They're just not as exciting as some people want to make them out to be. So if you are interested in seeing labs and such, again, ask those people. They might either themselves or they might have a grad student that would be willing to show you around. I had a mortgage guy come into our lab. He said, "This is the coolest thing ever. Can you make math?" Yes, I can make math. Of course I can. I don't want to. I actually ran the reaction that everybody blows themselves up with. I ran that reaction and hope it's a good reaction. It's not just used for math, but it was the happiest reaction of my life that didn't work because I didn't have to do it again. Because getting the liquid ammonia getting gas ammonia to become liquid ammonia is just really annoying. And I fumigate in the lab. It's good. So I didn't leave any time for questions. If you have any, please let me know. We could ask a couple questions probably. We can let people come in. Like, yeah, you can totally. Yeah, what do you got?
So when you're writing a series
Yes.
and you do some surfacey kind of like science, you follow your rules of how to make it work in your fiction.
Yeah.
As the series goes on and you do maybe need to provide more details, is there a point where you as a scientist are like, it's okay because I have buy-in to the story? Or do the same strict rules for keeping the science in your science fiction apply through like start to finish?
If I really love the characters, I really love everything, I'd probably give you a little bit of a pass later. Yeah, she's like, oh, because I totally did that, I'm sure.
They're already giving me a pass on a lot of characters, but it's okay.
Yeah.
We're family, it's cool, we're good.
Yeah, I think, as you get more, it's like, okay, you had to put something there, so I guess we can live with that.
Dune has that problem.
Does it?
Like the later Dune books after the initial three,
Yeah.
they're awful. They suck.
Okay. Well, it's the midichlorian problem. Like,
Yeah, they over-explain
Yeah.
everything.
exactly. Just, we try not to do that.
And she could probably take one more question and then we're gonna.
So, what is your take on the Alien, like the original horror movie in space? Because they don't want to go super into the science stuff, but there's still, like liquid nitrogen being used.
Yeah.
And, like, is that like the right level of science?
have not watched that in a very long time.
Okay.
It did not annoy me to the point that I would never watch it again, so that's
Okay.
probably good. Yeah, like water freezing from the bottom up, that'll all be done. There's like certain things, like
That's the
certain.
reason we have light fuckers.
Correct. So one of the remake sci-fi shows had that right away. Like they got frozen in something and it froze from the outside in, and I'm just like, no, it's not how that one works. And my husband's like, I agree. We're not watching episode 2. Like, there we go. Thank you. But it wasn't enough, but it was likely appropriate. Yes. I
Okay.
think a lot of the things are appropriate.
Any closing thought or anything that you want to share as a last thought?
Just think twice and ask people.
Thank you, Heather.
You're very
It was so
welcome.
nice to have you here. Awesome. And we still have 3 events left in the writers track. If you look on the GaryCon event site and just put in the words writers track, you will find all of those, and those all take place tomorrow. So hopefully we'll see you guys at some of those last ones.
With Fred.